Hi, everyone, and thank you for joining us for today's webcast, Database Indexes, Separating Myth from Reality for DBAs, Developers, and Application Users. My name is Amanda Greiner, Marketing Coordinator with GSI, and I'm very pleased to welcome our main presenter, Bill Rem. Bill leads GSI's database practice, is certified on multiple database platforms, and he's been a J.D. Edwards CNC administrator for almost 20 years. Besides webcasts, Bill conducts on-site training, creates video tutorials, delivers presentations at conventions and user groups, and writes a monthly article for the GSI newsletter, the GSI Insider. Now, before we get started, I wanted to give you a chance to review our safe harbor statement. And now for a quick overview of today's meeting, which will last about 60 minutes. First, we would like to take a moment to go over a couple of housekeeping items, as well as provide a brief company overview. Then I'll turn it over to Bill to get into our main presentation, which will last about 40 minutes. Next, I'll take a minute to go over our upcoming educational events. And finally, we will then wrap up with a 10-minute Q&A session. If you would like to submit a question, you can do so through the questions panel at the bottom of the GoToWebinar console window located on the right side of your screen. Please note that questions will be answered at the end of the presentation. So if you would like to minimize your GoToWebinar console during the presentation, just click the right-facing arrow key on the top left of the console. Clicking the left arrow key will return the console so that you can input your questions. And now I would like to give you a brief overview of GSI. GSI is a full-service J.D. Edwards consulting organization. We're an Oracle Platinum partner that was founded in 2004 and now has over 100 employees. We have offices nationwide and are recognized on the Inc. 5000 list of fastest-growing companies in the U.S. GSI specializes in project consulting, managed services, and cloud and hosting services, with all of our services backed with a 100% guarantee. GSI provides a broad spectrum of business, functional, and technical consulting services for J.D. Edwards, NetSuite, Oracle Cloud, Salesforce, ServiceNow, and other enterprise applications. In addition, we are a product development company that has many popular products, including Genius, which is our advanced monitoring and performance analytics solution for J.D. Edwards or any business critical system on any platform. Genesis, which is our load and stress testing application for system design, validation, or expansion for J.D. Edwards or any web-based business critical system. G Shield is our comprehensive security solution for J.D. Edwards, including password reset and two-factor authentication. Rapid Reconciler allows you to effectively manage your inventory, in-transit, and R&V reconciliation processes for any version of E1 or World. And Rapid Approval is a Salesforce AppExchange solution that streamlines the approval request process. And now I would like to turn things over to Bill for our main presentation and demo.
All right, I'm going to switch the thing to me here.
Okay.
And do you see my screen?
Yes, I can see it.
Excellent. All right. There we go. Well, let's get started. Thanks everybody for coming to this webcast. I like this particular subject. I could go on at length about it, and some people regret that if they ask me about it, but I am going to talk today about indexes and separating the myth from the reality for everybody, DBAs, developers, and application users. Before we get started, I wanted to let you know about one of the applications that are going to be featured in this webcast. It's SQL Developer. It's free. If you don't already have it, and this is for Oracle, but it can work with other databases. If you don't have it, go get it. If you do already have it, make sure you're running the latest version, or else you might not get the latest features. You can use SQL Developer to manage an Oracle database and run queries on other databases, such as SQL Server. Tasks in Oracle like data pump, adding indexes, and much more can be done through SQL Developer. Now, the webcast today is generally based on the Oracle database, but this information applies to virtually all relational databases. SQL Server Management Studio performs all the same tasks on SQL Server as SQL Developer does on Oracle. So if you're on MS SQL, you would use that tool. And I've got a video on the GSI website that describes how to download and install SQL Developer if you need that. The application I'm using as the punching bag today is Oracle's flagship ERP product called JD Edwards. JD Edwards is a competitor to SAP and has been around since 1977, which was bought by PeopleSoft in 2003, and Oracle bought PeopleSoft in 2005. And JD can run on Oracle, SQL Server, DB2 400, and DB2 UDB databases. And because of that, the software has a very interesting way of handling indexes, as well as many other aspects on databases and logic processing and much more. It's a great example to use, especially for this webcast, not only due to its unique nature, but also because JD documentation, training, and the application itself hides the true nature of the impact of the database on the application development and processing. So let's get started. I've got one crazy fact about indexes, and that is indexes at runtime. There's typically no relationship between what is defined inside the application and what exists on the database. And this is especially true with JD Edwards. Even though you added an index with a tool and used it as the basis of a query in your application, the database doesn't care about that at all. There's no connection at all between the two. And hopefully, I don't know if your mind is blown yet, but that's not to say that no application or report can force the database to use a specific index, but you can't do it in JD Edwards, and it's not that common anyway. So let's take a step back. What's an index and why would you need one? So your job here is to go find me a bottle of 2013 Han Pinot Noir. So go ahead and start walking. So how long do you think it would take to find what you wanted in this warehouse if you just were dumped in there? Days, years? Maybe you'd get lucky and find it right away. Now, what if I said, bring me all of the 2013 Pinot Noirs in the warehouse? I mean, that would be insane. I mean, hopefully they'd all be stacked right next to each other, but probably not. They might be stacking those wherever they can find some space. And then, how would you know if you've gotten them all, even if you walked through the whole warehouse? You would have to search every single bin in the warehouse. And wouldn't it be great if you had some kind of a map to show you where the stuff was? So a store map is a very simple index. It gives you a general idea where everything is, so you don't have to search the entire store. If you want a bottle of wine, you go to the beer and wine section. You need a steak, the meat market's over there. And indexes are like this in that they help you find what you need in a short amount of time. Now, database indexes are a little more complex, of course. If you were to look at Wikipedia, it says that it's a database index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes. It's important, and storage space to maintain that index data structure. So without an index, the database has to look through every row to find the data it needs to fulfill a request. And some might ask, wouldn't the database put the records in the right order? The answer is no, obviously. And the database, what happens in the background, it puts the information in the table wherever it wants to. But let's say it does consider order when inserting. The next question is, what order do the records need to be in? Is it on the first column, the third column? Is that the only column that will ever be searched? And what if you need data based on another column? I mean, that's what indexes are for, to point you to the data that you need. So an index is a subset of these table columns which can be sorted give a pointer to the full row of data in the table. And this allows the database to quickly find that data without having to search the whole thing. So because the data can be sorted, all the related information is in one spot. And once the database finds what it needs in an index, it looks at those pointers associated with the index to find the full information in the actual table. For example, an index on employee last names would quickly give you the location of all the rows in the table where that last name exists. So, their first name, maybe their social security number and their salary and things like that. It will show up for all those people. So a quick note on table data. When you insert and delete rows from a table, as I mentioned before, the database arranges this information however it wants to. Even if you insert a list of rows sequentially, like from a spreadsheet, the data might still get put in the table out of order depending on how the database feels like it should do it. The database puts the data in the table in the most efficient way that it can. It might insert it into an empty space or append it to the end of the data file. You just don't know. And that's another reason indexes are important. You just don't know how the data is going to be inserted. So for example, the data in this table is not in any particular order. except despite inserting it by last name. So let's say you delete a record and it leaves a little bit of space in the table. When you insert a new record, the database may put it in the empty space, or it might tack it on to the end. It depends on how much each action costs, and also whether or not you've chosen to leave extra space in for indexes to expand into. So the database may think it's easier to put that record at the end, and maybe 10 minutes later it would have put it in that other space. So you're going to get jumbled stuff in there, so indexes are very important. So let's talk about the kind of things people think about with indexes. So here's the myth or reality. Indexes always make things faster. So when you think your processing is slow, will adding an index always make it run faster? Bet you know the answer to that, and the answer is no. And the key word is always. Indexes can make performance better if they're well thought out. Unfortunately, they might do nothing at all, or make it worse. Usually people's first reaction is to add an index when they think something is running slower than it should. Adding an index could be the result of analysis of the process rather than a first step. So is the report running slow because of a missing index, or is it just a badly written report, or the application, or there's some processing going on that you don't know about in the background? People who want to add an index immediately, it's usually a response to kind of bad application code or third-party apps. Sometimes an ad hoc reporting can cause slowness because they often start searching for non-index values, or put together a lot of joins, or maybe they're doing a not in condition, which forces a full table scan. So most of the time when somebody says they want to add an index, it's just that they think that's going to solve it. They've written a report, it's not running right, and they say, please add an index. There are times when an index is required, but it is possible to change the behavior of the application or the person. And the database decides how best to run the SQL anyway, so even if there is an index, it may choose to do a full scan, like I mentioned, with a not in condition, or maybe the database realizes you're going to select 75% of the data in a table, so it's still going to be very slow. And indexes do add overhead. Many indexes every index is an extra write, and I'll be talking about that in a little bit. You just don't really want to add indexes based on what you see in the application. You have to look at the SQL statement and the logs, check the execution plan, which a DBA can do for you. Inside JD Edwards, for a JD Edwards application specifically, when somebody's on the web and there's many steps between the database and the display, because the web server has got to go your web session's got to go to the web server's got to go to the database, then it's got to run its query and bring that data back to the web server, and that takes up memory on the web server, and then it comes back to your workstation. So you're holding up memory in a couple of different places. So your results that you get back could be related to network, or maybe the heap space on your web server. So that's why you may be overloading something else in that chain of stuff with your application, and an index wouldn't do you any good anyway. So let's move on to the next slide here. So when do you not need an index? So here's an example. So on a table you're using, there's an index. This is the index, A, B, C, and D, and your report only needs columns A and B to get what it needs. Unfortunately, your report is running longer than it should, and you decide to add a new index just for column A and B. Unfortunately, your report is still running longer than it should. You create the index, maybe you're using JD Edwards, and you generate these indexes, and it's just not running any faster. It's because you didn't need an index on column A and B. You already have one with those columns in it. The database can use part of an index when they start with the same column, and databases can also combine columns. So see, we've already got this index right here that has A, B, C, and D, and so any queries that go to A and B will still use that same index. So all you've done by adding that extra index is to create another write on the database. So databases can also combine different indexes and columns to service these requests. Now, it's not as fast. The latest database versions can even use indexes in the middle of the index. It's still not as efficient. In a case where you have tons and tons of queries that might need column B first, might be better to create an index for that. But databases can put these things together. So if you have more indexes than you need, so what? Some people think that adding indexes that aren't used probably isn't an issue. But as I've mentioned before, it can be very much an issue because every additional indexes cause another write to the database. So you insert a record or change a record, it's got to change that record in every index that's on the database. So then, see here we've got A, B, C, D, A, B, and C, D. Every time somebody updates that thing, it all ends up as a write. So here, one small table with a few indexes, or one index is like this one here. If you add another index, that's not really a big deal, right? But if you have extra indexes on a huge table that is used hundreds or thousands of times per minute, you will notice an impact. So this is the FO911. It's a very large table in JD Edwards. It's used for general ledger, and it's hit all the time. And this table is 141 columns and ships default with 36 indexes in the latest version of JD Edwards. That means every single insert, update, or delete is done 37 times on one of the largest, most frequently accessed tables in the system. You definitely want to think twice or 3 times before adding an index to a table like this. Reports going to this table are better off being written with the existing indexes in mind. And if you were to look at your FO911, for those of you that have JD Edwards, you will see that up to half of the indexes on your system have never been used. So here's the next myth: more columns in an index is better. And I'm just going to give you a hint for all the rest of these questions. All the answers are no. So when you make an index, should you include as many columns as necessary as you want? But really, once you get past 7 or 8 columns, you're not really getting much benefit. Now, this is just an example. The actual benefit you get from a large index will vary. This is just for illustrative purposes. Every column on an index helps the database narrow down the location of the data that it needs. And at some point, you're going to be about as narrowed down as you possibly can get. And adding the extra columns provides little or no benefit. So if you've got, you can see here in my just kind of a, I just made up this example, but it's kind of based on reality, is that if we had a 4-column index, you probably would narrow this down almost to like 3 or 4 records. But so adding 4 additional columns wouldn't speed anything up really even noticeably at all. And then you keep adding more and more columns, and this gets into some people want to have an index on the, on every column in the table, which is kind of silly. But all they're doing is causing it to scan through the thing longer, through the indexes longer and longer for every extra row, and it takes up extra space on the database. So many column indexes are not that great. Now I know that some tables need to have lots of columns in their indexes. So I've seen primary keys that hit the maximum number of columns. Like in SQL Server, the maximum number of primary key columns is 16. So if there are some needs for that. Like you have so many bits of data in there that the only way to find a unique value is to have all these extra columns. But I would say that pretty much, virtually, I don't know virtually all, but many of them are not going to require such a huge index. And this is another reason why you might not see an improvement by creating an index with more columns. It might just be a slow report. Next one is, should I generate indexes in my application? If you have that functionality, I know JD Edwards does have the functionality to be able to generate indexes from within the application, and generally no, you don't want to do that. So here's in JD Edwards, this is a specific example to JD Edwards, but inside one of the tools, it's called Object Management Workbench, you can find a table and you can click this button to generate indexes. Now, not all applications have this functionality, of course. In JDE, when you click this button, it tells the database to drop all of the indexes on the table. That's step 1, drop all indexes. Then it looks at the JD Edwards, the specifications for that table inside JD Edwards, and creates a SQL command that creates the indexes one at a time from scratch. It's very similar to rebuilding indexes on a standard edition database. and even Enterprise Edition without specifying the online option. And this is a huge mistake. What you probably didn't know is that the moment you click that button to generate the indexes, is that what I mentioned before, it drops all the indexes. And this might not be a big deal on a small table with not many columns and a couple indexes, but it's a huge problem on a very large table like the F0911, which I talked about before. With those 36 indexes, drops all 36 indexes, and the table's got millions of rows, so it's got to go through and generate all those, and the table is locked for the duration of the index rebuild. And so since that table is used by most operations in E1, you end up with a frozen application. And that table is so large, it could take 24 hours to regenerate them all. And even worse is there's really no way to roll it back. You just have to let it continue until it's done. Now, as a side note, if you have a table, if you have an F0911 or table that would take 24 hours to generate all the indexes or rebuild all the indexes, then probably you need to look into table compression. The physical size of a table on disk contributes quite a bit to application slowness. So if you have a 300 gig table, in fact, we had this happen at a client. They had a 350 gig F0911. It took about 24 hours to regenerate all the indexes. They compressed it, and the table size went down to, I can't remember off the top of my head, but it was less than 10 gigs. And the regeneration time, is using it as a metric, went from 24 hours down to 30 minutes. So physical size of the table is a huge deal. Now, what if you just rebuilt one index? Even if you're going to generate or rebuild a single index, you're still going to lock the table for however long it takes. So that is still a consideration. And as a side note, in JD Edwards, you can generate single indexes, and that's with the P95-150 application. So you're not limited to, because if you click this button in OMW, it does all of them. But if you do P95-150, it will generate all of them. I mean, you can generate a single index. So how do you do it in the database? This is the better way to get index changes, and this is SQL Developer. It's significantly faster, it doesn't kill your performance, and you only change what's necessary. So you open SQL Developer or SQL Server Management Studio, they both can do it, and you make the index change directly on the database without doing anything in your application. You can create these without defining them in JD Edwards or any other app at all. And this can help if you want to test your changes before you commit to anything. And you might wonder, how does your application know the indexes are there if you didn't tell the application about it first? And in JD Edwards, you modify the table specs to show that there's an index there. Then the truth is, applications don't actually know or care what indexes are on the databases. You might care, but the application doesn't unless you force it to. In JD Edwards specifically, behind the scenes, E1 simply issues SQL statements to the database without any regard for indexing. Generally, only developers and CNC administrators, application administrators, need those specs inside the application to facilitate their work, and the transactions flowing out of JDE or any application to the database don't look at those specs at all. So when a transaction arrives, it's the database that decides what index to use, if any, at all, and executes a statement in whatever way it thinks best. In applications like JD Edwards, there's another limitation. Even though you can rebuild indexes through the application, it only creates standard indexes, the basic index that database uses. If you need a special kind of index, like a function-based index, bitmap index, or SQL Server with included columns, you can't build those in the application. You can only put those on the database. And that's not to say that you shouldn't let your application know about these new indexes if that's a part of what your application does. JDE Enterprise 1 does. Once you have figured out what your index is and you verify that it's going to work, you do need to go back and add that into the table specifications. Even if it refers to a kind of index that the application can't create, you put a placeholder in there or something, you're going to need those specs for updates, upgrades, new development, and not to mention other people who may not know about your new secret index. So by creating indexes manually on the database, you not only save huge amounts of time, but you can test indexes very easily. If you create an index and it doesn't do what you thought, you can easily remove it and try another one without having to go back through your software development cycle, or you can turn them on and off. You can make them hidden and unusable, yet still there in case you did really need it in the end. Next myth or reality: can my report force the database to use a specific index? No, but sometimes maybe. So not all applications or reporting tools allow you to send hints. Optimizer hints is what they call them, table hints in SQL Server, and JDE is one of these. And even if you could do it, you really wouldn't want to second guess the database optimizer anyway. You might have at one point an index tuned up just right for the query and the table as it exists now, but what happens when more data is added and statistics change? What happens, the database is probably not going to change its execution plan because you're forcing it to do it a certain way. And what happens if you update the database to a new version and the query optimizer changes? Eventually, the index that you're forcing it to use won't be the best one for the job, but the database is almost always going to use it anyway. You've told it to do so, and it's going to keep doing it. And now that works in most of the cases, but the database can still override a table hint or an index hint. So even if you force it to do it, it may not always get used. So this here is a JD Edwards development tool. This is to expand on, can you force the database to use an index? And this is one of those confusing things that developers learn. JD Edwards developers learn is that when you're using this JD Edwards development tool, you have to associate your fetches, your data fetches, with indexes that exist on the table. And so this is where it comes in that people think that JD Edwards controls how they're run. People think that since they had to pick an index to create this IO statement, that the database would use that index specifically. It does not. It's only there to help you develop the application better. And so what happens is, if the developer doesn't see an index that they like, they create a new one that looked better and fit better with whatever is going on in their mind. And unfortunately, like I said, indexes don't work that way. You're just making something that makes it better for you to develop the application. So you see, when JD Edwards sends a SQL statement to the database, and pretty much any application, the database decides which index. It doesn't matter what you choose in your table IO or what extra indexes you have defined. You can regenerate indexes all you want and rebuild them, and has no effect on index usage at runtime. But with this kind of approach to indexes, you end up with a lot of indexes that don't get used at all, and some of them are duplicates of existing indexes. And as we covered previously, these extra indexes create an additional read or write on the database, whether they're being used or not. So how do you handle these unnecessary indexes? You get rid of them. Kill all indexes. So what about the indexes shipped with the application? You can drop those too. In applications like JD Edwards, let me go back to I like that robot, don't you? Anyways, in applications like JD Edwards, you have to go into the app and remove them from the table specs if you remove them from the database. Otherwise, if someone ends up generating them from the application, you get a bunch of indexes back. So here's this is the result. This is the results of a query I ran on a SQL Server database that shows index writes and reads sorted by writes descending. In these top 50 tables, there were 640 million writes and 0 reads. And if I added up all the writes on all the tables with 10 or less reads, and there were 830 million writes, which is crazy. You see this kind of thing in software that's been around for a really long time, or that were just designed for online transaction processing and reporting to do both of those, or data warehousing. So online transaction processing, OLTP database, that kind of database, you want fewer indexes and tighter queries. In a reporting database or a data warehouse, there are few or 0 writes, so the indexes don't grow and the data doesn't change. So you can have as many indexes on those databases as you want. It doesn't affect performance. But having a zillion indexes on an OLTP database does affect performance. It slows it down. So if you have a tremendous amount of reporting, you might consider having 2 separate databases, one for reporting and one for OLTP. That way you can go crazy on the reporting database or the data warehouse with indexes while keeping your application running very smoothly. Another thing to consider when you're working on these custom indexes, and this is mostly for JD Edwards, there's so many applications out there that do things differently. I can't address them all, but if you upgrade or update your application, it could change the table structures and indexes that you're relying on. So how does the upgrade process handle it when you have these customizations? You're definitely going to have to do some index maintenance, and in the case of JD Edwards, if they add an index, the index IDs are shifted around. So inside JD Edwards, when indexes are created on a table, they are created with an index ID value, and that ID value is created sequentially, and each new index will be created with the next sequential index ID based on the existing index with the highest index ID value. Now you can change this ID value manually if you like, which is kind of a complicated process, and I'll tell you about that in a second. So this index ID you can look at this within the TAM spec file, the DD key H, or the central objects table F98712. It'll show you the index value. So if you create a new index inside Enterprise One specs, and then a new index on the same table gets delivered and it has the same index ID in like an upgrade or an ESU or something, then the ESU process will replace the custom indexes with the new standard index for the table, and then it will reappend the custom index after the standard delivered indexes. And your custom indexes now have a higher index ID. And this is all within JD Edwards. It has nothing to do with the database. So this impacts table IO statements based on this index because they're often keyed to the index ID and not the actual index. So you can actually have an issue inside the application with the renumbering of the index IDs. And there was a bug, and when I did this presentation last, there was a bug that was still open. 17307376 custom table index gets renumbered. So they were requesting a change to the logic so that indexes are not renumbered to cause the event rule issues when they're keyed by index ID. Okay, I've just talked terrible about every index ever existed, but let's say you've done your homework and there really is no good way to change your application without sacrificing the output. You've looked at what you've got, and you've determined that this query will be run many, many times throughout the day, and the index will save a lot of time and money. So now you just create the index. So as I mentioned before, you can create the index in the application. I still don't recommend it, even when you know, because not a lot of people know about the individual index generation tool. But even then, you have to lock your table while the index is created. Only on the database can you use Enterprise Edition features to create an index online. And just as a side note, even with an online index creation in an Enterprise Edition of the database, there are two very brief moments where that table is locked, and it's super, super fast, and it's just at the moment when it needs to swap the index over, swap the new index in to get rid of the old one. So there is like a microsecond of a lock, but normally that's not a big deal. But if you do it through an application, especially JD Edwards, the table will be locked as long as it takes to build that app. And in JD Edwards, they can only create B-tree indexes on Oracle. And any indexes that, if you've added custom indexes to a table and you generate them through the application, and those indexes are not defined, or maybe they're just placeholders, like I mentioned, let's say you have a function-based index on the database, it's going to create only what it knows about. So you're still going to have development notes to say, if this ever happens, if this ever gets regenerated, don't forget to go check the other indexes because they might be gone now. In SQL, you can go directly to the database, use SQL Developer, SQL Server Management Studio, or just go right down to the command line interface, create the individual indexes, create them online, and you can also create the indexes with many different arguments that you can't get through the application. So some things to note is that again, any applications, all applications will use any indexes that exist for the table in the database, regardless of whether or not it's defined in the application. The index is not defined inside an app, must be recreated manually, or if there's something that the application can't create. And you also need to understand how these software updates and changes and patches and things change the index structure. Like I said, in JD Edwards, all the updates and upgrades will keep these custom indexes, but they'll move them to the end. And this can affect the I/O event rules because they key on the index ID. And this actually didn't take 45 minutes, so I am now done, and I'm going to turn this back over to our MC. And that's right here, Amanda. So there you go.
Okay. Can you see my screen?
Yes, I can see it.
So thanks, Bill. And now I want to cover a few follow-up items and then move to our question and answer section of the webcast. Our webcast today is part of GSI's free ongoing educational webcast series on JD Edwards. Our upcoming webcasts are listed on the screen. To view our most up-to-date schedule, please visit getgsi.com/webcasts. Okay, and just a reminder that GSI will be attending the Southeast Regional User Group Holiday Casino Party in Atlanta, Georgia on December 13th. And again, if you want to register for that, just go out to getgsi.com, select News and Events on the menu, and under JD Edwards, select Conferences/Events. GSI provides extensive free educational resources for the JD Edwards community, including our weekly educational webcasts, monthly newsletter called the GSI Insider, our online resource center where you can access our on-demand webcasts, white papers, etc., and on-site and virtual workshops. If you would like to sign up for our weekly email reminders for upcoming webcasts, our monthly newsletter, or create an account to access our resource center, go to getgsi.com, go to Platforms on the main menu, select JD Edwards, and select the appropriate link on the left. Okay, well, I see we have already had several questions submitted online. I would like to remind everyone that if you would still like to submit a question, you can do so using the questions panel in the GoToWebinar console window on the right of your screen. If you minimized your console earlier, please click the left arrow to redisplay the questions panel. Okay, so our first question comes from John, and John asks, how do you force the database to use a specific index?
Okay, so there's a couple, well, it depends on the platform. For example, in SQL Server, there is what's called a table hint, and these can only really be done at at the lowest level. So if you have the ability to program, if you're developing your application directly on the database and doing SQL Server development or something like that, then you can throw these hints in there. And in Oracle, they're called optimizer hints, and you're basically telling the database, hey, I strongly recommend that you use this index. But that being said, if you go look up index hints or table hints, optimizer hints, the very first thing that you're going to see is you probably shouldn't do it. You don't want to second guess the database optimizer because it's normally going to know better than you what it is supposed to do. So as far as the specific details, you would have to look up for your database. Oracle, like I said, optimizer hint, and SQL Server is a table hint. But those can't be issued from within JD Edwards.
Okay. Thank you, Bill, and thank you, John. Our next question comes from Carlos, and he says, hello, we have a S091 with 37 indexes. We know many do not add value, but how would you approach to optimize the indexes then?
So when you have, if you look at, like I had mentioned on the report, there were, in this one database, I'm actually pull it up and count the number, 650 indexes on a typical JD Edwards installation that are used less than 10 times ever. And if I look at the zeros, and it's different for every JDE client because the different modules that people have. So in this particular client, 475 indexes have never been written to. So what do you do about those? Normally when I do an index maintenance that involves dropping them, I'll drop maybe 10 at a time, 20 at a time, and then let it sit. All right, and I won't drop them actually. I'll make them unusable, hidden indexes, or take them offline within the application. And that way the database continues to hold them there, but it doesn't actually get rid of them. And the reason that's good is that if you do need to recreate it, it can come back online very quickly. But once you have determined that your application is not suffering for these indexes not being there, then you just drop them and get rid of them. And then you go into the JD Edwards application and remove them. You'll want to take development notes, because if someone else comes in after you, they will wonder why it's not there and maybe rebuild them and send them back out. And you'll need them also for upgrades, updates, and things like that, which are going to replace any JD Edwards indexes that you have removed. And that may be for a good reason, because it might need it now.
Okay, thanks, Bill. Our next question comes from Kimberly. She asks, even if we may not want to force an index, can we not put a specific index on a BSVW and then use that BSVW on the UBE or APPL, then forcing the use of the index in this particular instance?
So yeah, there's actually a couple of follow-ons on here that I'm reading from Kimberly that I may modify the answer. So anyways, a business view, JD Edwards business view is a logical construct within the application that brings together, it's a view. It's just like a table view, except it's only within JD Edwards. So that still behaves the same way. It's still going to go out and leverage the same indexes. So the same way that anything else does. So, some business views are just a subset of columns on a single table, and some can be multiple tables joined together, but you still run into the same thing. It's still going to use whatever index is the best for it. So if your business view is constructed to exactly work with an index that already exists, then it'll be fine. But with the business view, you're going to see in the JDE logs, it's going to be, if it's a multiple table, you're going to see joins and unions, and makes it more complicated. So the more tables you bring together, the more chance you have of it taking a long time.
Okay, thanks, Bill. Our next question comes from Sangeetha, and it's, do we have a rebuild index within application to fix the fragmentation?
No, actually, fixing fragmentation, that's an interesting topic. Because of the way that database storage, all of the new kinds of storage that are out there, especially when you're using virtual disks and things on virtualized systems, you're going to have index fragment. Everything's going to be fragmented all over the place. And there's some schools of thought that say, don't worry about fragmentation that much, because it is, by the very nature of your infrastructure, always going to be fragmented. So defragmenting them within the application on logical volumes, in virtual volumes, is not going to add that much of it's not going to add that much stuff. But anytime you rebuild an index, you're going to find a huge improvement. If you want to start defragmenting indexes, honestly, there's not a whole lot of benefit in modern systems that you're going to see from it. I'm not saying don't ever do it, but I just wouldn't expect a whole lot of improvement from that. Normally, rebuilding indexes through the application, depending on the app, is not going to be the way you want to maintain your database indexes, because you never know how it's going to do it.
Okay. The next question is also from Sangeetha, and it's how to handle missing indexes.
Right, so within JD Edwards, there's a missing index report that you can run in the proof mode that'll show you any that are missing from specs. But if you find that you are missing an index, for example, using the SQL Server missing index report, that's another way, another thing entirely. If you are in a spot where somebody or some application or maybe Foglight or Spotlight or some monitor says you need an index, then first thing is, don't trust an application that tells you need an index. You want to look at everything that it says, because in the example of the SQL Server missing index report, it doesn't take into consideration the indexes that already exist. It doesn't take into consideration the other indexes that it's recommending in the list. So you could get a bunch of similar indexes recommended for a table. Plus, you need to also consider how many times does SQL Server say that would have been a good idea. If it says 10,000 times, then yeah, maybe that's a good idea. But if it shows this huge benefit to this index, but it's only ever been sought out 3 times, then you don't want to do that. So however you decided that index was missing, make sure that it really is going to benefit you to put it on.
Okay. And our next question comes from Jeff, and it's, can you throw out a name of a database tool that recommends an index for a UBE?
Sure. Well, so it's on the database side, on SQL Server, we simply use the missing index report, which is built into which is actually part of SQL Server. There's a script you can run that will pull out all those things. And it may also be a standard report on the database. But like I said, the missing index report is a really great starting point. But it's not going to show, it's going to show every possible missing index for every operation that's going on the database. It won't show specific UBEs. It'll just show you everything that it thinks need to be added. Go ahead.
Oh, sorry.
That's it. Yeah, next question.
Oh, okay. That actually appears to be the end of the questions. So thank you, Bill, and everyone for your questions today.
Oh, there was one more question I saw in here I wanted to answer real quick. Kim asked, does it matter if we create indexes directly on the database and never in JDE? No, it doesn't matter, except if you're going to upgrade or add an ESU or a patch or something like that. And the reason that somebody might do that is if you want to put in a function-based index, or in SQL Server create one with included columns. Those are impossible to define inside JDE. So you may decide, I'm just going to create it on the database and forget about it in JDE. Yes, you can absolutely do that. The database will use it. The JD Edwards will use those indexes. And you know what? You could delete every single index spec out of JD Edwards and not have any defined at all inside JD Edwards. And it will still work the same way as it always has, because it's the database that decides what to do with it. Hope that answered the question.
Okay. So thank you again, Bill, and everyone else for your questions. And as a follow-up from today's webcast, we ask that you complete a short 1-minute survey when you exit. You'll be receiving an email with a link to our resource center on our website, where you can access the recording from today's webcast as well as a copy of the presentation. And after today's webcast, we will do a drawing for the $25 Amazon gift card, and anyone that attended the entire webcast will be eligible, and we will notify the winner. And if you have any follow-up questions, you can contact Bill or I, and we will get back to you. Our contact info is on the screen. Thanks again for attending our presentation, and have a great day.